Welcome back, students. We're starting a new unit on waves. The reason that we have to have a whole unit dedicated to waves is because the energy oftentimes moves in waves. The purpose of this video is to define what a wave is and to define certain wave characteristics that we can measure on the wave. So I'm going to go ahead and draw a wave and then I'll point out these characteristics. Okay, so here's a picture of a wave and I have this dotted line in the middle. This dotted line in the middle is called the equilibrium position. The top of the wave is called the crest and the bottom of the wave is called the trough. Alright, now we have a name for the tops and the bottom of the wave, and we also have a name for the height of the wave, and that's called the amplitude. Alright, so the amplitude is the height of the wave, and is also associated with how much energy that wave is carrying. So the higher the amplitude, the more energy moving through that wave. In terms of like a sound wave, a high amplitude sound wave would be like a loud wave, right? There's more energy moving through louder sounds than quieter sounds. So those loud waves have higher amplitudes. The amplitude is the measurement of how tall the wave is. Another important measurement is how long the wave is, and that's called the wavelength. Okay, so this is a wavelength. The symbol to represent wavelength is a Greek letter, lambda, kind of like a T that's like toppled over. The way you can measure a wavelength is by going from one spot of the wave to the next spot where it repeats itself. So you can go from crest to crest, or trough to trough, or if you want to start at the middle, right here I see it's coming down, so I mark that spot and look for where it repeats itself. Right here. I can see the distance from here to here is just half a wave because it's not repeating itself right here. It's doing the opposite. It's going from positive to negative to positive. Alright, another important characteristic with waves, because they are moving through time, the time it takes for the wave to travel one wavelength is called the period. In other words, the period, we represent that with a capital T, is the time it takes for one cycle of the wave to pass. Another word we use to describe waves, kind of like period, is the frequency. So the frequency is a measurement of how many cycles pass in 1 second. Okay, so frequency is pretty much the inverse of period. Time and the number of cycles split. Period is how much time it takes for one cycle to pass, and frequency is how many cycles pass in 1 second. So for period, we just use seconds as the unit. For frequency, there's a unit called hertz. Alright, the last characteristic that we need to talk about is the wave velocity. The velocity of the wave can be found by multiplying the wavelength times the frequency. And that gives us this equation. And velocity, of course, has units of meters per second. Okay, so that sums up all the different wave characteristics. I'll show you one quick example of how to find some of these characteristics on like a graph of a wave. Okay, so here I've drawn a wave on a graph. I have some numbers that I can try to use to measure the amplitude and the wavelength. So I can see that the tops and the bottoms, the crests and the troughs, both reaching 5 and -5. So that tells me that the height of the wave is just 5. It's just the distance from the equilibrium position to either the crest or to the trough. Okay, so I know my amplitude is 5 meters. Okay, I remember wavelength is the distance of how far it takes that wave to start repeating itself. One cycle of the wave. So I'll start like here at the beginning. I see it's moving up. Okay, and then there's a dip. And then here it repeats itself, it goes up again. So from this point to this point, that is one wavelength. It's one cycle of going up and down. So I can see that one wavelength is 4 meters. Okay, and let's say I wanted to find the period of the wave, and I knew that it took 5 seconds to complete 2 cycles. So my period would be 5 seconds divided by 2, which would be 2.5 seconds. Okay, so that tells me that it takes 2.5 seconds for one wave to pass by. If I wanted to find the frequency, I have to find the inverse of the period. To take the inverse of something, you have to do 1 divided by that thing. So 1 divided by my period is going to be my frequency, which is going to be 1 divided by 2.5. Alright, and this gives me 0.4 hertz. Alright, lastly, if I want to know the speed of the wave, I know it's frequency times wavelength, so I can do 0.4 times 4. Alright, and this gives me that the wave was traveling at 1.6 meters per second. Okay, so that's how you can find all those different wave characteristics on a particular wave. Hope this video helps you guys understand all those different terms. Thank you. Hope to see you next time.